Gartner, the well-regarded technology company, just called the semantic layer a must-do foundation for AI for data and analytics. If you work with data, this is something that is becoming a critical skill and will be a critical skill for the future. Whether you already know what a semantic layer is or this is the first time you're hearing the term, today I'm going to break down what it is, why AI made it critical, and two different approaches to building semantic layers. Let's start with talking about what semantic layers are. A good and kind of funny analogy is a restaurant. So you don't walk into the kitchen when you go to a restaurant and say, give me 200 grams of protein at 375 degrees for 20 minutes. You look at the menu and you order the food by name. Think of a semantic layer as a menu for your data. Instead of writing the raw SQL against tables named TBL, TXN, HIST, table transaction history, you ask for revenue by category last quarter. And the semantic layer translates that into correct tables, joins, and filters. Without a semantic layer, say you have three analysts doing the same analysis, answering the same question. They can get three different numbers depending upon which date column they use, whether you use transaction date, execution date, apply date, say those are the three date columns. If they use those different dates to answer a specific question around what was the revenue by market segment, then they'll probably get different answers across that different time period. I found this blog that pretty much illustrates my point here, where an engineering lead said that they had a financial metric defined 60 different ways across their organization before they had a semantic layer. And once they had a semantic layer, they only had one single definition that was the source of truth. And as a data person, I can certainly relate to this, where I know at different jobs I've had, there have been so many nuances as far as what date columns to use, how you aggregate data, whether you use a count distinct or a straight count, or if there's certain columns you need to subtract from the column that you're summing in the first place. Having a single source of truth definition column can be extremely helpful and save a ton of lost time when trying to do an analysis successfully. Now, semantic layers have existed for decades. For example, Looker has had LookLM and Power BI has had DAX measures for over 10 years each. So why has this become so important and why is everyone talking about it now? Well, when you point AI, a large language model, at your database, it sees column names and table structures. It has no idea what revenue means in your company, which date field to use, how to aggregate data, or how you would define a term like an active customer. All of those are internal context that you have in your head as a data analyst when you're querying the data. A really interesting study that hits home on this point is this Spider 2.0 study from Cornell University. Basically, what they did is they took real enterprise databases from BigQuery and Snowflake with over 1,000 columns, and they had this benchmark for their models to hit the accuracy when they were given text to transform that into SQL and correctly query that database. Using the simple data in Spider 1.0, the first time they did this study, the models actually hit 91% accuracy of transforming that text into accurate SQL. However, with the introduction of the enterprise data, the models hit only 21.3% accuracy of transferring that text into correct SQL. So basically, the models got a lot worse when they encountered a lot bigger and more complex enterprise data. And this is the illustration of why the semantic layer is important. It can raise that accuracy by giving AI the business context it needs to successfully translate the text you give it into the SQL that is answering the right question. Without a semantic layer, essentially your AI is querying blind. It's the difference between guessing what the right SQL is to write and having a smart AI that is writing SQL that actually understands the data and how it corresponds to the business. So we know what semantic layers are and why they matter. Now, here is where it gets interesting. There are two main different ways that you can build them. As one of my previous coworkers, shout out Hangsha, defined it, the two categories of semantic layers are bundled and standalone, and they solve the same problem differently. Bundled semantic layers are built directly into your existing platform. For example, Snowflake has semantic views, Looker and Power BI have their semantic layers, and Tableau actually just released Tableau Semantics. The advantage there is very little additional setup. If you already use that platform, the semantic layer is right there inside of it. The trade-off here is that your metric definitions are tied to that platform's format. Other tools can still connect and query the data, but the definitions themselves are not portable across platforms. Standalone semantic views are an independent layer that sits between your data and multiple consuming tools. dbt has MetricFlow, Cube serves metrics via API, and AtScale does native BI protocols, just to name a few examples. The advantage is you get one metric definition that is portable and platform independent. Any tool connects the same way, but the trade-off is that there is additional infrastructure to build here. Now, I have linked a full breakdown of every tool in both categories that I've researched with informational links in the description here, as well as in this repository I will share with you. Now let's actually get our hands dirty with building some semantic layers. We're going to use Snowflake for our bundled solution and dbt MetricFlow for our standalone solution, so you get a sense of what both types of solutions might look like. All right, my glasses are on, so it's time to work. Here's the scenario. We have Claude Code here with two different questions, where really the business question here we're looking for is what the total revenue is by market segment. And we have this hooked up to Snowflake. If you're curious how to hook up Claude Code to Snowflake, check out that card link above. What will happen once we actually send these commands to Claude Code is entirely dependent upon what we've set up, whether or not we have semantic layers, as well as the context that we've given Claude for it to work with. And as far as the data we're utilizing here for the semantic views, we are using Snowflake's built-in TPCH sample dataset, which contains customer, line item, orders that we see here on the screen. There's no setup needed, and every single Snowflake account has this. As far as prerequisites that you might need to follow along, you need to make sure that Cortex Analyst is enabled in your Snowflake account. And by default, that should be enabled for newer Snowflake accounts. You want to make sure that you have write access to create the semantic view. And then you want dbt core installed for the standalone demo once we get to that point. Now back in Cursor here with our two Claude Code sessions, you can see I've altered the prompts just a little bit to have it specifically utilize the schema I want it to, and then also write out the results in analysis A CSV with the script, and same for B over here. I've also deleted the other folders I had up here previously with the SQL and dbt, just to make sure we're completely starting clean when running this analysis. That way it doesn't have any of that context it could utilize to get the right answer. So now I will click enter on both of these, and we will come back once we have some answers that we can compare. All right, the results are back, and we can see the total revenue numbers are in the 40s from this screen. The net revenue numbers from this screen are in the 20s. And maybe if you had the semantic layer in place, you could say net revenue and total revenue should be interpreted in the same way. Now, I'll be honest, and I admittedly set up this demo so you would get different answers. And I think it's a fair criticism to say that, all right, well, what if I asked it in the exact same way? Wouldn't I get the same answer? And most likely, yes, but it's also possible no. And this is just to demonstrate the importance of these semantic layers with giving the right information to AI, where the actual context for how to interpret the data lives inside of the data. And another workaround might be to actually put this inside of your Claude Markdown, your context files in your repository. However, that is local to that repository, whereas a semantic layer lives inside of the data. So from wherever you're querying it, whether it's inside of this repository or inside another, it's going to have that context to know how to interpret this question around revenue. And if we take a look inside of the actual SQL files here, we see that they're very different SQL. And the problem here isn't that Claude didn't write the right SQL, it is that it didn't have the context to know what exactly you're defining net revenue and total revenue, and if you're defining those in the same way, given that there's multiple columns that exist within the schema that could fit that criteria and extend that to all of the columns in your database. And so I would say here that AI is not wrong. It doesn't have the context and it doesn't have the business definitions that it needs to be right. Imagine putting in an analyst and saying, hey, analyze this data on day one without giving them context and walking them through your databases. It's essentially that sort of situation. With the stage set here, now let's create the context that AI needs. And we'll take a bundled approach first with the Snowflake semantic views and Cortex Analyst. All right, I've started a new Claude Code session, and we can see my prompt here for Claude Code, where I am going to ask it to actually create the view inside of Snowflake, the semantic view, that is. And this is just to demonstrate the power that you can utilize AI to build out the infrastructure for your AI to be successful with your data. And I will paste this prompt in here, switch to plan mode, and we will let this run and come back once it has a plan prepared for us. All right, so Claude has come back to us with a plan here for the semantic view, and we can see within this context, it is optimizing it for the Cortex Analyst and any other AI querying it, making sure that it will get consistent results. And if we scroll down here to the DDL, the data definition language, we can see that the semantic view has the tables, relationships, dimensions, metrics, all defined along with comments and synonyms for all of the different fields and tables relevant within it. That way, when AI is querying from this data, it has all of the knowledge of what is supposed to be used for what. And if you're unfamiliar with the syntax for creating a semantic view in Snowflake, it should seem fairly familiar if you've been working with data, recognizing the relationships as that's defining the join criteria between the different tables. Your dimensions are your characteristics for your data. Your metrics are your measures, so your numeric values and how you actually aggregate them. And one helpful trick to aid Claude in producing correct semantic views is that I actually have it within the Claude Markdown file, the correct DDL for how it can actually produce these views. That way, when I ask it to create a semantic view, either in this case or another case, it knows how to do that within Snowflake. So with this, I checked all of these other portions of the plan and they look good to me. We will click yes, bypass permissions, and we will check back in once Claude has some output for us to look at. Claude has come back to us with output, and we now have confirmation that the semantic view has been created. We can go over into the Snowflake interface first to check this. So to check whether or not your semantic view is there, one option you have is to go to AI Studio, Cortex Analyst, and then we can see our semantic view here for TPCH semantic view. And we can go in our playground and enter a prompt here asking the Cortex Analyst within Snowflake. What was the total revenue by market segment? And then it gives us this interpretation here, which is really helpful to make sure that the analyst, the AI in this case, is interpreting our question correctly based upon how we've defined the fields, the dimensions, the measures, and the tables and relationships between them. And we can see here that it gives us the total revenue, market segment, all of that information that when we go back over to our repo here, it matches analysis A's output. To check the semantic view another way, we can actually scroll down here and utilize the Snowflake MCP. It has a tool to access the Cortex Analyst, and we can issue queries or prompts to that Cortex Analyst saying what was the total revenue by market segment in plain language, and we should get the same experience that we saw in the actual UI. So we'll click enter here and wait for it to come back. And using the MCP, it came back with the answer that we expected. And you can see it encountered a small error here, but was able to figure out and ultimately able to get us to this place of complete validation that we have the semantic view working in exactly the way that we want it to. And hopefully now you can see the value of this, where this Cortex Analyst, it's grounded in the semantic view, and we're going to get a consistent answer every single time, not because the AI got smarter per se, but because the definition is now explicit and the context is embedded inside of Snowflake. As you've seen, the bundled approach keeps everything in Snowflake, which works great if this is the main location where you have your data. But what if your data infrastructure is spread across different systems? That is where the standalone approach comes in that we will demo next. We are taking the same playbook that we utilize for Snowflake for dbt MetricFlow, and we have a very similar prompt here. A couple things I want to point out. It is describing what we want to build with the TPCH table, so we're not just referring it to the Snowflake data. Additionally, we have it doing a MetricFlow semantic model YAML file, and I've asked it to configure MetricFlow for dbt if it's not already configured, which I have not configured it yet, so this will be the first time I'm setting it up. We will click enter on this prompt here, let it run in plan mode. While it runs in plan mode, I want to go over here to talk about MetricFlow very quickly, where basically it's the backend for dbt that powers the semantic layer of dbt. I will link this documentation that describes more in depth what it does and how it works, but think of it just similar to what we saw with Snowflake, where it's defining the dimensions, measures, and giving AI the actual practical language to work with the data without having to explicitly interpret the technical column names and technical table names. Back here in the screen, the plan has been written out with the dbt project with MetricFlow semantic layer, and the context is basically the same as what we did before for the bundled Snowflake layer, but just adapted for dbt and MetricFlow, where it's going to first install MetricFlow using the pip install dbt MetricFlow Snowflake, and installs dbt core, dbt Snowflake, and MetricFlow in one shot, which will be great. Creates the dbt project configuration, creating the staging models, and the MetricFlow time spine here, the MetricFlow semantic models and metrics for all of the similarly named entities and descriptions that we had with Snowflake, where it's actually describing the data and referencing the specific models that are present with dbt, and gives us the 6 tasks of verifying it. So what we will do is we will click yes and bypass permissions and watch this go off and running and come back once we have the output again for how this has built the semantic views using dbt MetricFlow. Coming back, we have the output and it has successfully worked. We can see all of the different changes that it's made throughout its process of running. And now we have the MetricFlow CLI configured as well as the DBT project for this repository with this data configured. And one note, I did configure the DBT MCP server for this repository while I was waiting for this plan to finish. That way I can utilize the MCP server to query the MetricFlow semantic view as well. And if you're curious how I set up the DBT MCP server, check out my other video above about DBT and Claude Code. As a validation step here, we will run this prompt to have it run via the MetricFlow CLI and the DBT MCP to get the total revenue metrics against the semantic view. And here we will have it run. And while that's running, we'll actually switch over to this DBT docs screen I spun up. And we can see that we have our project here with our different models, staging, my face is covering it. But the more interesting portion of it is that we have our semantic models, where we have customers, orders, line items, and then also our different metrics here that we can be able to see via the visualization interface on the right-hand side. And now we know that we have this semantic data, this semantic model actually embedded in our DBT project. Switching back over to our screen with Claude Code, we can see that the prompt has run. And I actually went and checked this before recording this section, as there are a couple of things I wanted to clarify. Firstly, the MetricFlow CLI query worked exactly as expected. As we just saw with our DBT docs, it shows the semantic layers present within our local DBT projects. However, DBT MCP using the DBT show function tool that is available via the MCP did not return exactly what I was expecting, because I was hoping for list metrics, query metrics, or get dimensions like the DBT MCP server has available. However, it only has that feature available for DBT Cloud customers. So you need to have a DBT Cloud account where this semantic view is actually hosted in the cloud to be able to query your data with the DBT MCP server in that way. That said, for my local DBT project, this works perfectly fine, and I'm still able to get the same metrics saying, hey, can you please look at total revenue by customer segment, market segment, and it gives me the answer that I would expect out of it. And as far as how these DBT MCP tools work with DBT Cloud, essentially they call the MetricFlow API, as I understand it, and they're able to get those governed definitions. And so whether it's an AI agent, BI tool, or a data application calling this layer, they can all query that same metric via the API having that single definition. And you can also access it via the CLI. It just changes the syntax from the MF query to the DBT SL query. In conclusion, with this standalone approach, your metrics are version controlled and portable. So if I had other data in other data warehouses, I could actually hook this up to DBT MetricFlow and get the semantic views created that would help inform my AI for the future to query that data correctly. Now, to wrap up this section, I am going to ship off these changes using my git ship command, which I covered in another video linked in the card above. And now we have come to the end of this video. If I'm going to leave you with some thoughts, I would say the semantic layer is becoming a core skill for data professionals, and it's only going to grow in its need. Whether you start with what is built into your platform or go standalone, as we saw, both of those approaches work and ultimately depend upon your environment. The most important thing is understanding this concept now puts you ahead of the curve when it comes to how AI is going to be adapted for data and analytics. and how data and analytics are going to be adapted for AI. If you want more information about semantic layers, I have the links in this repository for all the other tools, as well as in the description of this video are all the relevant links for everything that we use today. If you found it helpful, please like and subscribe to my channel. I really do appreciate it. And as always, thank you so much, and I will see you in the next one.